One, ready, go.
Welcome students. We are going to discuss today units and addition of vectors. So why is important to talk about unit for this laboratory? And basically because whenever we are traveling in the world or whenever we are in this class, units are physical things that we can measure. Is to have sense to numbers and several things. For example, almost the rest of the world use the international system of units denoted for the letters SI. That is for the French. I'm not very good in French, but that means Système International, something like that, in French. Yeah. But in United States is one of the few countries that still we are using the United States customer system, or sometimes denoted by USC. So unit, for example, for length that we have in the international system as meter, are going to be using 4 feet or sometimes inches. So in this case, it's going to be part of this laboratory, understand all this transition, because the books that we are using right now, all the scientific work are going to be based in the international system. In fact, that system is based in 7 units. Units to measure physical quantities. For example, the physical quantity of length is going to be the meter, denoted in the international system with M. We are going to have the unit of time, unit second, denoted for the letter S. We are going to have the unit of mass, denoted for kilogram, and the unit of temperature. Where the unit is going to be Kelvin. With capital K. Basically, in this laboratory, those are going to be the basic units that we are going to handle during all the semester. We have another unit that also are going to be important in the basic system of international unit, that we have the unit for minimal amount of matter that we call mole. We have the electric current. That is ampere. Something that you are going to use in physics too. Ampere. And the luminous intensity. That is candela or candles. But we are going to focus in this system and how to change between the international system and the United States customer system. Also, don't think that the units are going to be only for science. We are talking that this transformation of units are going to help you to travel in the world. Sometimes I have seen some reports and students telling me, Professor, I obtained 5. I say, 5 what? But you need to tell me what unit is additional to that unit. For example, it's very common in this region in Las Cruces. We are very close to the bridge. We are very close to Mexico. When we say $2, it's not the same like 2 pesos. If you tell me, okay, I have a 2, I can give you 2 pesos or $2. Or even, if you want, 2 British pounds. So, in these 3 cases, we have 3 different numbers too, but we have different units. That is exactly the difference that we have. Also, we need to learn how to change between different systems. So whenever we have an equivalence statement is something that you are going to find one table how to transform between one units to another. There are some units that there is a simple multiplication with fraction, and you can do this very simple. Let's start to use. Whenever we are talking about an equivalence statement, we have, even in the same United States customer system, for example, 1 foot to be 12 inches. This is exactly how we express an equivalence statement. But an equivalence statement is not really useful unless you transform in a conventional factors. A conventional factor is only express this in the fractional way that can help you to cancel or transform from one system of units to the other. Let's try one example. Suppose that we have 7.3 inches and we want to know how many feet are that. Okay? So what we need to do, pay attention in physics first to the units. What units do you have? Those are units of length, so at the end we need to have units of length. If we have suddenly from units of length to units of time or different, it doesn't have sense, physical sense. So you need to keep exactly the physical meaning all the time. So in this case, I want to obtain in both cases, inch and feet are units of length. We can do this transformation. I'm going to multiply times a fraction. This fraction is going to be obtained from the equivalence statement. Here, we never put, but whenever we have one unit in front of one number, we have a multiplication. So the opposite of one multiplication, we have a division. So let's choose the same unit right now in the opposite, division, to let me cancel that. Okay, the number 12 is associated with this. And we are going to express 1 feet with 12 inches. If you apply the multiplication, this affects only to the numerator, so I have 7.3 inch times 1 feet divided 12 inch. Inch divided by inch going to be 1, or as probably in many classes before you said we cancel. In fact, we don't cancel. If you divide one number for itself, always going to give you 1. That is the magic number for all this. And the only unit that survives is exactly the units that we want. Okay, 7.3 divided by 12 is going to be, thank you, 0.608 feet. That's exactly what we have. So you are going to find in your notes several examples to do that. But you say, how is possible? But what happens if we have from a different change? Okay. This equivalence statement can be applied even to monetary systems. I mentioned that we are very close to the border, so many of us used to go to Mexico, and why not have some parties in Mexico? Suppose that you have in your pocket $20 and you want to travel there. Right now, the equivalence statement, something that we call the change rate in the economical system, we have that $1 is going to be 18.5 Mexican pesos. Okay, let's see. Let's transform $20 into how many Mexican pesos? We are going to apply exactly the same that we just learned. In fraction, use the equivalent statement, but pay attention to cancel the operation of the unit. We have multiplication, so we are going to write dollars in the denominator, the division. So we have 1 associated, we keep 1. So we have here 18.5 pesos. Okay. I'm going to multiply 20 times 18.5. We can multiply the units with the units. Dollars times pesos. And in the denominator, if you want to use a symbol, whenever you have in fractions, you can express any integer divided by 1. And take 1 times 1, it's going to give me 1. And the only unit in the denominator is going to be dollars. After multiply 20 times 18.5, we are going to have 370. We have dollars times pesos, and 1 times 1 is 1. We have dollars here. Here you can see that we have numerator and denominator the same units, so everything's going to give me 1. Usually we hide the number ones and we never show this. So we simplify this. We have 370 divided by 1, 370. We have times 1, we can hide it, and we have at the end pesos. There are several methods to find this, but in physics we are going to have more than 1 unit sometimes. I mentioned we have 370 pesos. What happens if we want, if after the party we want to return to America? Okay. We are going to have left in your pocket like 67 pesos. So how many dollars we are going to have to return? Let's try to use the same principle. Pesos times, identify right now what unit you have there, multiplication. So I need to use same unit, pesos, in the opposites. Multiplication, division. 18.5, and I have the numerator $1. So it's going to be 67 times 1 pesos times dollar, and in the denominator 1 times 18.5 pesos (67 times 1 is 67). 1 times 18.5, 18.5. I have my units, pesos times dollars and pesos. From here again, you can see pesos divided by pesos, going to be 1. 67 divided 8.5 is 3.62. Okay? Hardly enough money to return and take the bus. So be very careful. So you can see how important are going to be the units, because they are going to tell you how you can transform. But as I mentioned, in this class we are going to have combined units, more than 1 unit at the same time. So how we can change those units? So basically it uses this same example, but 1 unit at a time. It's going to be the best option. Let's try right now for units of velocity. Something that we are going to find. It's very common that in the driving system of America, we are going to find a speed limit in miles an hour. So the speed limit that we have here in Las Cruces in the freeway is around 65 miles an hour. So, and you are going to see that sometimes it's going to be necessary to find, if you travel to other countries, they are using in kilometers per hour, or in this class, for example, we are going to use in meters per second. How to make this different transformation? So, if you pay attention, we are going to use units of length and units of time. So, we have two different systems with one number associated to that. Okay, so in order to make the first transformation, for example, 65 miles an hour, we can extend this hour. Remember that we have one number 1 associated to the number. And make the transformation. What is the equivalence statement? So you need to choose one unit. I'm going to go directly for miles. Okay? Don't try to work with both units at the same time. It's going to be very complicated. So use one and try to focus and change only one unit at a time. So my equivalence statement is 1 mile equal 1.6, approximately 1.6 kilometers. Oh, 1.609 to be exact, kilometers. Okay, so pay attention. We have this unit in the numerator. That means it's a multiplication. So I need to cancel this, the same units, but in the denominator. So they are going to cancel. So write the next part of the equivalence statement, 1.609 kilometers, and solve the system. I'm going to multiply numerator times numerator, 65. You can make groups, times 1.609, and the units with the units. Miles times kilometers. And we have 1 times 1, hours, miles. $65 times 1.609 is going to be 104.59. Okay? From here we can see that we have miles divided by miles. It's going to give me 1. So at this point I have kilometers per hour. So we already have the first transformation. But what about miles per second? Okay, so in a next posterior to this part, I'm going to explain that we are going to use scientific notation, and it's going to be very simple if you remember some prefix. Let's see. So we have right now 104.59 kilometers an hour. Let's try to change right now the hours unit. Okay. I hope everybody remember that the equivalence statement, in 1 hour we have 60 minutes. Oh wow, that looks a little bit difficult because we are looking for seconds. And we have that 1 minute, we have 60 seconds. Okay? That is how is powerful this technique, guys. We can make several transformations, one after another. So, identify that we have in the denominator of division the unit that you want to change right now, hours. So I'm going to choose 1 hour, and the next part is going to be in the denominator, 60 minutes. With this, automatically, I'm going to transform in 1 the hours, and I'm going to have my answer in kilometers per minute. But we want to have in meters per second. So I'm looking right now, seconds. Focus in there. Okay. I can make another multiplication of fractions, and I have the unit that don't like me too much yet, because it's not the unit that I'm looking for, minutes in the denominator. So I need to cancel in the positive. Minutes. 1 minute is equal to 60 seconds. Perfect. This is going to be 1, and I'm going to have in kilometers per second. I have the units, the first part that I want. Okay, so I'm going to multiply all the numerators, and I'm going to multiply all the denominators. So it's going to be 104.59 times 1 times 1. It's better if you make groups, if you don't have too much practice. Number with numbers, and units with units. Kilometers, I already canceled the other units. Remember that we can divide by 1 without affect the number. 1 times 60 times 60. And we have seconds. And that is going to give me 100.59 times 1 times 1. That unit for itself. 1 times 60 is 3,600 seconds. Okay? I can make the division, numbers with numbers, and I'm going to get, give me 1 second. Get 104.59 divided 3,600. 0.029 approximately kilometers per second. Okay, but still is not the units that I want. We are going to be learning in the next section how to change this. In fact, we are going to add something new for this class, probably, that is called scientific notation or powers of 10. So kilo usually refers to 1,000. So what we can do, because that prefix refers 1,000, we can interchange that letter for 1,000. And we are going to have meters per second. So at the end, it's going to be 1,000, approximately 29 meters per second. That is our final unit. Okay, I hope if you have questions, let us know about this section, because it's going to be important whenever we have more than 2 units. So remember, choose 1 unit at a time until you get the unit that you decide. If you choose, after that, choose the second unit. You can start numerator first or denominator first. It doesn't matter. It's going to follow the same techniques you are going to write. But what happens when we have some prefix like this one, kilo? It's part of the scientific method. Try to simplify. Whenever you have in the international system of units, was designed to try to simplify transformation of units, and don't think too much later about that. Because later units that you are going to use for force, for example, newtons, if you move to the basic system of the international system, everything is going to give you automatically. But if you don't transform it correctly from the very beginning, you are going to have a little more harder time to find. Still you can do it, but it's going to take you more time, and you are going to have the probability to have an error in your answers. Let's try to introduce, if you see your tables in your graphics, you're going to have a table of prefix. I'm going to use the table that you have in page number 5. A table that has several numbers, several units, and some prefix. Let's try to choose some of them. For example, let's try to use for capital T, that is for tera. That is expressing the units a trillion. 6 times 12. You're going to see that is denoted for 10 to the 12. This number is basically telling me how many zeros do you have after the main numbers. So you can see 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. So that we call tera. Probably you are familiar in use terabytes. So what is telling you? That you have trillions of bytes in that quantity. We can find also units in that table that are going to be very small. Suppose that we use something like this. Something like that. So 3, 6, 9. You are going to find negative power, so numbers that are very, very small. This is the realm basically for signs. Only in signs you are going to find very little quantity associated to some units. The prefix that we can associate is one lowercase n that corresponds to nano. This is going to be very important whenever you are dealing with light, that we use and measure for nanometers, oscillations that probably you are going to see in the lecture, and we are going to see in nanometers. Okay, and let's try to use another important prefix for this class that we are going to use constantly, centi. Basically, we are going to be using 10 to the minus 2 centi, or the lowercase m, milli. Double L? I think so. Milli. So we're using very little units. Another unit I already used, that is very common, lowercase, okay? It's basically to express 1,000. 1, 2, 3 zeros. Kilo. That we use a lot for kilograms, that we use a lot for kilometers, if you want to change unit of length. Suppose that we have to change some units in this laboratory, that we have 200, and we are going to express kilograms, and you want to express in units like grams. So identify the units that you want to find, and simply you can replace the prefix for kilo, the number that is associated, or the power of 10. You are ready? Transform the unit. You don't need to do nothing else. If you want to simplify a little bit more, that is very common in science, you can move your decimal point, but that's going to be part of another class. What about if you want to transform for another subunit? And that means you need to move your decimal point. Whenever you have to move your decimal point, I want to refer some technique that is called the inverse ruler of powers of 10. Why is inverse? Because the negatives are to the right and the positives are to the left. Okay, in this technique, suppose that we are going to express that quantity that we have 2,000 kilograms in milligrams. What we need to do? Okay, the first things that you need to do whenever get rid of the prefix. The only one that we need to try to keep is the kilogram, but in this case, it's not going to be necessary. We need to get rid. It's telling me in the problem. Times 10 to the 3 grams, and identify what is the power of 10 associated to the next prefix, milligrams. We need to be very careful because it's a very common mistake that many people think that we have meters, grams. So we need to be very careful in that part. So try to remember that a prefix is basically the meaning of pre, that means before, and fix, that means attached. So one prefix never can be alone. It's always before and attached to one unit. If you see only one M, it's meter. If you see things like this, we have milligrams. But what about if you have something like GM? That means grams meters. Only when it can be a little bit confused, it's important to write meters times milligrams, for example, to denotate that we have along the unit. Okay, let's return to this example. So identify the prefix that we want to change. Times 10 to the negative 3 grams. So we can use the fact that we never write a decimal point at the end of all the zeros, and in your inverse ruler of powers is telling me the position, the exponent is telling me the position where is that decimal point. So if I want to move to negative 3, I need to move my position 1, 2, 3, 4, 5, 6 times to the right. So keep that number and I write 1, 2, 3, 4, 5, 6 times to the right. And I can replace this for the milligrams that we are looking for. So that is exactly how we can change really fast from one unit to another, moving your decimal point. There is another technique that is a little more powerful than this, that we can multiply times 1. But to do that, you need to learn that we have some properties of units. Feel free to ask to your TAs, but I'm going to give you one example. So I'm going to use the same example. 2,000 kilograms transformed to milligrams. This technique consists, again, identify the power of 10 that you have associated, identify the power of 10 of the units that you want to transform. That is the very first part. Write that number, the number that you have here, write directly in this part, the number. At the same time, cancel one properties that we have for powers of 10 is the addition of the exponents. Whenever we have the addition of the exponents, it's going to give me 3 plus minus 3 is 0. 10 to the 0 always is going to be 1. So basically, I am multiplying times 1. So I'm not changing nothing. So I'm going to keep this times 10 to the minus 3 in the shape of the milligrams and solve the addition of these exponents. That exactly is going to give my answer. How is that possible to be exactly this number the same? Remember, that is telling me how many zeros I have after the point. You can see I have 3 zeros here, but later I have to add 6 zeros. So 1, 2, 3, 4, 5, 6. This is exactly the same. It's what we call scientific notation or powers of 10. So it's a technique really powerful. With a little practice you can master, and you can solve, instead of using many zeros, you can simplify a lot of your problem. I hope this can help you to change all the units. Feel free to ask to your TAs, to the instructor, in order to solve as soon as possible